Okay. So in vectors, we need to know column vectors in terms of 2D, 2-dimension, and a 3-dimension. In 2-dimension, we have vectors in maybe 3, 2. In 3-dimension, we have vectors maybe in 2, 3, 4. So this one is for the x-axis, y-axis, and this one is for z-axis. So now we are talking of an object at point that is in 3-dimension. There is a y-axis, x-axis, and a z-axis. After this one, vectors in 3-dimension, we are also expected to know position vectors. Position vectors is actually maybe coordinates in terms of x, y, z, but coordinates are given with reference to the origin. So we have now the vector OP, which will be x, y, z. This is actually coordinates, but now they are written in a column form, in a column vector. So we call them position vector. Then another thing that we are supposed to know is notation. Vector notation means if we write vector A, we must denote it by saying vector A, B vector B, C vector C. We must have that sign for the vector. If it is written in terms of direction, vector A, B, we must include that arrow to show that we are talking about vector. Still, we can write AB. We put this down on. So this one is very necessary under representation of vector. So every time you are working out, try to do this so that somebody can know, you know how vector is represented. After all of this, we now move to something else. We also we are moving on, and I think you are taking some bit of notes. Next, we want to move further. So in vectors, we have said one, we are supposed to know column vector in 2D and 3D. We should know how to represent a vector, vector notation, how to write position vector. Then another aspect under vectors is how to find the midpoints. Midpoints, we said midpoint M between point A, which is 2, 4, and a B, which is -3, 2. How do you find the midpoint M for this one? So the midpoint, we said it is average of 2 plus negative 3 over 2 and 4 plus 2 over 2. So midpoint will be equals to negative 0.5 and 3. So midpoint is very necessary. We are supposed to know that. After knowing this one, now we move to form 3, where we have vectors. In form 3, where we have now vector in terms of I, J, and K. So we call them column vectors in terms of I, J, and K. This is column vector, but under unit vectors, where I, so if we say 2I plus 3J minus 4K, this is a column vector P. So this column vector, it is actually the same as 2, 3, negative 4. But now this one is written in terms of I, J, K. This one is written in terms of now the column vector. So this is column vector because I, we said I stands for 1, 0, 0. J stands for 1, 0, 1, 0. And K stands for 0, 0, 1. So if we replace this one in this vector, we are likely to land at this. Well, another thing that we are supposed to know in vectors, so we have vectors in terms of I, J, K, as we want to see in illustration of an example. After doing that, we need to know ratio theorem. The ratio theorem, we go straight. In ratio theorem, we said that a vector, position vector may be O. We have then point A, B. AB, that's the vector AB. There must be origin somewhere where these vectors are coming from. So we have vector OA and vector OB. If we have a point M, which is dividing, let me not use M. Let me use something different. I reserve M for something else. Let me say this is X. A point X is dividing the line AB in the ratio 3:2. And this one is vector A of vector B. And this one is vector A. So vector OA is equals to A, and OB is equals to vector B. So in this case, how can we find vector OX? Find vector OX. That's why we said we can use ratio theorem, where we said we kind of focus on 3, the total ratio, AB, X divides AB in the ratio 3:2. So 3 over, let us not use a definite number. Let us use an arbitrary unknown, divides in the ratio m is to n. So the ratio ax to xb is equals to m to have our ratio theorem that says we focus on this one. So it is m vector ox will be equals to m over m plus n. That is the total ratio, then b. So we focus on m to this side, and n will go to this side, plus n over the total ratio, m plus n, and then a. That's how we use ratio theorem to determine the position vector OX. If we don't want ratio theorem, there is an analytical way that we are going to commonly use in answering many questions under ratio theorem. So this one lies under something we call proportional division of line. A line can be proportionally divided into a certain number of segments, and then a ratio is stated. So, and under proportional division of a line, we have internal division, if we have the line AB, a point M will divide AB in the ratio 4:3. So we say M is dividing line AB internally in the ratio 4:3. Then we have external division. So the ratio here is AM to MB, which is 4:3. External division, another line PQ can be divided externally by a point M. So our line is PQ, which is being divided by M. And point M is outside the boundaries of line PQ. Then we have the ratio is to. So we are going to have a point, the ratio we have now is PM to MQ. From P to M, in total we have 5 divisions. That is 3 plus 2, then 2. From M to Q, we have 2 divisions, but our direction was PQ, but now we are moving MQ. It is against the direction, so we indicate a negative on 2. So the ratio PM to MQ is 5:2, meaning that we are going against the direction, the initial direction of the line PQ that is being divided by M. So when we want to see a ratio which is stated in terms of a negative somewhere, it means what we have is external division, or the element of external division is stated in the question. All right. And finally, we are going to do application of vectors. Here we apply vectors maybe in a parallelogram. How would it behave? To apply vectors in geometry, like in a trapezium. How would vectors behave in that one? And then we do use the idea, because there is parallel lines in a pair of parallel lines in trapezium. So we want to use the idea of parallel vectors, and we use the idea of collinear points. And of course, we know in parallel vectors, one vector is expressed as scalar multiple of the other. We say it is parallel. We haven't touched that one. Another vector is expressed as a scalar multiple of the other. So we say the vectors are parallel. For collinear points, the two vectors are parallel, and there must be a common point. We are going to prove that one in our example. Generally, this is what we are going to apply in answering questions. Now anything somebody wants to seek clarity before we go to answering questions? Now we can see we are a full house. And I believe you have taken a few of notes. Okay, let's go ahead and try one example. Vectors. Try your paper 1, question 22. No, let's start with a simple one. Try 1, paper 1, question 14. Try 1. We are in our books. Try 1. Question 14. Let us see how it is behaving. The coordinates of points A, B, and C are 0, -4, 2, -1, and 4, 2 respectively. Use vectors to show that the points A, B, and C are collinear. Very good. Good. Question 14. Nimesoma lakini mwingine asome. Irene, soma hiyo. It's good to know that we are together.
The coordinates of points A, B, and C are 0, -4, 2, -1, and 4, 2 respectively. Use vectors to show that the points A, B, and C are collinear.
Good. When we say the points are collinear, it means they lie on a straight line. So A, B, C. When points lie on a straight line, we say they are collinear if they lie on one straight line. Then we have the coordinates of A as 0, -4, coordinates of B as 2, -1, coordinates of C as 4, and then 2. So how can we prove using vectors that the points lie on a straight line? I want you to mark this one in a very clear way. We come up with two vectors. So if we have 3 points, we are likely to have 3 vectors. We have vector AC, vector AB, and a vector CBC. These 3 vectors are okay. We can find the 3 vectors, but we don't need 3. We only need 2 vectors. So let us work with vector AC and vector AB. So come up with the 2 vectors. Vector AC, it is point C in column form minus point A in column form. A is 0, -4. And then we have our column vector 4 and then 6. That is vector AC. Vector AB, point B at the position vector 2, -1 of point B, then followed by minus point A, 0, -4. And then we have vector AB as 2, and then 3, I think 2, 3. -1 minus -4 is like 4 minus 1, so 3. So we have 2 vectors. So come up with 2 vectors. We have decided to have 2 vectors, decided to have vector AC and a vector AB. Another person can even decide to have vector BC and AC, or to have vector AB and BC. So it is your own creation. But so long as you come up with 2 vectors, then if the points are collinear, then vector AB, vector AC can be expressed as a scalar multiple of the other vector AB. Vector AC is equals to KAB. That is if they are, so we prove whether the 2 vectors are what? Are parallel. So if the 2 vectors are parallel, one vector can be expressed as a scalar multiple of the other vector. So substitute what we know, 4, 6 is equals to K into 2, 3. Open brackets, 4, 6 is equals to 2K and 3K. So 2K is equals to, so K is equals to 2. And 3K is equals to 6. So K is equals to 2. If these values of K are equal, it means we can comfortably say that vector AC, it is equals to 2AB. And you can see I've included the, in our working, we must be including the vector notation. So how are we going now to conclude? So we say this one is a must. You have to say this one. You go ahead and say vector AB, AC is parallel to vector AB. And A is a common point. Hence points A, B, and C are collinear. This is what is going to award you the last mark. Are you getting the process? By the show of hands, Irene, I can see your hand is up. Okay.
Excuse me, Cha.
Yes.
Cha I'm asking, cha hapa si tumepata 2k is equals to 4 na 3k is equals to x. Alafu kakuja ukaandika k is equals to 2 na k is equals to 2 na k ya kwanza ndio 2 ya pili ni 3. Cha mbona unasema zote ziko equal?
Oh yes, something that we have not done, maybe we skipped. I think we have divided this one by 2, divide this one by 2. 4 divided by 2, k is equals to 2. Divide this one by 3, this one by 3. 6 by 3, 2. We skipped that process. Okay?
Yes.
Yes. Another concern? No, we are good. So that's the process I want you to stick to when we are proving whether the 2 points, the 3 points are collinear. They lie on a straight line. And typically that is what we are going to do. So we come up with 2 vectors. We express one vector as a scalar multiple of the other vector. This one. We say that if that is possible, the 2 vectors are parallel. And these 2 vectors must share a common point. In this case, A is common. Then now we conclude and say the points A, B, C are collinear. They lie on a straight line. I think we are done with that. Let us go to another example. Another example, maybe from your end, somebody tried something and it never worked out. I want us to move to an example that is talking about the column vectors in terms of I, J, K. Let us try trial 4, paper 1, question 16. Let us see whether it has column vectors. Trial 4, paper 1. Trial 4, paper 1, question 16. It's not behaving. But let's try it because it is still on parallel. Let me check who is reading for us. Susani alisoma jana, Rosia alisoma. Eunice, read for us question
16.
Question 16.
Vector P passes through points 10, 20, and 6, 10, while Q passes through points X, 12, and negative 10, negative 18. If P and Q are parallel, find X.
Find X. This one, we must come up with the idea that if vectors are parallel, one vector can be expressed as a scalar multiple of the other. So we say if the vectors are parallel, vector P passes through 10, 20 and 6, 10. So we can get vector P. So vector P is equal to, let us find the vector P. So I can start with the 10, 20 and so 10, 20 minus 6, 10. so that we get the vector. This one is negative, it is 4, 10. Vector Q. Vector Q, we take this one, x12 minus negative 10 and negative 18. This one gives us x plus 10 and 30. I think so. 12 minus 18. That. If the two vectors are parallel, then we can have vector P is equals to K KQ. If they are parallel, one vector can be expressed as a scalar multiple of the other vector. Now, if that's the case, then substitute the values of P and Q as we know them. So the vector this is vector P, this is vector Q. So vector P 4, 10 is equals to K x plus 10, 30. The upper side will give us 4. This equals to 4x plus 40. We open a bracket, k times x, k times 10. And the lower side will give us 10. This equals to 30k. K times 30. We can easily divide by 30 both sides, so that we have k as equals to 1 over 3. Yes.
Yeah, kwanza yenye tumesema 4 tume open brackets za hapo juu.
Oh yeah.
Tunafungua brackets na k.
Oh, tunafungua brackets. Oh, no. Something is wrong. Sorry for that. Our 4 is not there. 4 is not there. It's not there. Let's open brackets. Sorry. That's good observation. K times x, it is kx, and k times 10 plus 10k. That one is okay now?
Yes.
Yes. So we have 4. This equals to. We have 4. It is equals to k times x plus k times 10. Okay. Then we have the lower 10. This equals to k times this one, which becomes k times 30. So 30k. Let's divide by 30 by 30. So we have k is equals to 1 over 3. Are we in agreement? K is a third, Debbie?
Yes.
Yes, because we are told the two vectors are parallel. So it means what? The values of k must be equal, must be the same. So the values of k are the same, so we get back to the first equation and say 4, it is equals to k, that is a third times x. Then plus 10 into a third, because we are told that this thing is what? It's constant. K is a constant. And then if they are parallel, the k we get from equating the upper side, it is the same k we are getting in equating the lower, the y's components and the x components. So in this case, we work out. So 4, it is equals to and that x plus 10 over 3 multiplied by 3 all through by 3. Whichever way you use to solve an equation, you can solve. So we have 12 is equals to 3 times 4, 12 equals to x plus 10. Then to let hii hapa, x is equals to 2. So the value of x is 2. Are we together in this? So we are using the idea that we are on parallel vectors. One vector must be expressed as a scalar multiple of the other vector. If you don't remember that one, things will not work out well. So that's why we started by getting two vectors, vector P and vector Q. Vector P became 4, 10, and this became 10, x plus 10, 30. If they are parallel, vector P can be expressed as scalar multiple of Q. So then substitute what we know. We know the value of P is 10, 4, 10. We know the value of Q is x plus 10 and 30. Opening brackets. After opening brackets, we get 4 is equals to kx plus 10k, and we get 10 is equals to 30k. From here, we can work out for the value of k a third, substitute in the upper equation, then finally we get our x to be equals to 2. Beautiful. Let us now go to a 10-mark question. We'll try one that has 10 marks. No, this is a gambling nation. We can, by gambling, somebody, let us pick one randomly, so long as it is in section 2. Let us go to trial 5, paper 2, question 22. Trial 5, paper 2, question 22. Niko kwa paper 2 kweli? Yes, paper 2. Tumesema trial 5. Trial 5, paper 2, question 22. Trial 5, paper 2, question 22. I think ndio hiyo. Is that the question? Okay, all right, let's work with this. Mtu ajitolee kwa kusoma. Beth, soma hiyo.
In the figure below, M and N are points on vector OQ and vector OP, such that vector OM to vector MQ is equals to 2:3, and vector QN to vector NP is equals to 2:1. ON and PM intersect at X. Given that vector OP is equal to P and vector OQ is equal to Q expressed in terms of P and Q. Command 1 vector 1.
Good. And this is a typical question that normally we encounter in our working. But the best way to answer the question, bring the information you have into the diagram. For example, we are told that M and N are points on OQ and QP, such that OM to MQ is 2:3. So you locate O to M. O to M, 2 divisions. O to M2 and MQ 3. Don't look at proportionality by the use of our eyes. We simply work with the numbers we are given. So O to M is 2 divisions and M to Q 3 divisions. Usianze kusema MQ ni ndogo kuliko MOQ. Those are unnecessary conflicts. Then QN to NP. So QN is 2 divisions and NP is 1 division. ON and PM intersect at X. That one can be seen. Then part A, we are told, given that just a minute. Given that given is tukwe. All right. I think I'm back. Given that QP is vector P, QP, you indicate the direction. The direction is QP, is vector P. And OQ is vector Q. So indicate the direction OQ. Direction is very important in vectors. Expressed in terms of P, vector P and Q, ON. So you come here and say vector ON. You follow the routes. Try to follow the easiest routes and the routes that you are going to avoid. You are going to avoid moving against the direction as much as you can. At times you may not avoid, but try to follow the easiest route and the route that you are likely to avoid moving against the direction. Of course, if you move against the direction, indicate a negative. So ON, we are going to move from O to Q. I think the easiest route is OQ plus QN. Of course, we can do with the OP plus PN. It is still the same thing. But what do we have available for us? We have vector OQ, so it is good to use that one. We have vector QP, we can use that one. So try to have the navigation that is likely to make your work simple. Then substitute the vectors we know. We know OQ is vector Q and QN, vector QN is a fraction of QP. So QN is a fraction of P of QP. So it is 2/3 QP. Vector Qn. How do you arrive at this vector here? We have Qn over QP is equals to, from Q to N, we have two divisions. From the ratio Q to N, two divisions. Then now Q to P, they are 1 plus 2, which are 3. Then Q cross multiply times QP times QP. This QP will cancel. So you remain with 2 over 3 QP. So it is 2 over 3 QP, and the QP is vector P. You are done with the first one. Ni nani atafika huko? Right. We are good. We have increased by 1. But all of us, we are in yesterday plus Abigail, so we are okay. Anybody who has not exactly seen what we have done? So vector ON, try to do a navigation that makes your work easier. So you have the 2 marks. Vector PM. Yes.
Here for Q and vector OP. Equal vector OP ndio is equals to P.
Ilikuwa vector. Wait. My reading is imesoma kama Q. Let's agree what we do. Okay, whichever way it will work, but now it change the equation, eh? Hi.
Yes.
Mimi niliona hii kama ni hatujaenda mbali sana, we can change, eh?
Yes.
Sawa. Let's change. This is vector OP. So vector OP ndio Q what? Ndio P, si ndio? This is vector P. Let's work with that, eh? So hiyo ingine haiko hapa. So we get back to square 1. Sawa. Let's now see the vector we are finding is ON, si ndio?
Yes.
Vector ON. For us to find vector ON, we need first of all vector PQ. So vector PQ. Tutafute vector PQ kwanza. ON, our direction is this one, eh? ON will be equals to OP plus PN. Sawa. Vector ON is equal to vector OP plus PN. OP plus PN. OP plus PN. PN, it is equals to 1 over 3 PQ. PN is a fraction of PQ. All of this one. So we need vector PQ, and the vector PQ, we need vector PQ. Vector PQ is equals to PO plus OQ. Plus OQ. And PO is against the direction, so it is minus P. OQ, it is Q. So we are moving against the direction PO. The initial vector we had is OP. So PO negative P, and OQ vector Q. Then we we get back and substitute here. So vector Pn would be a third into negative P plus Q, opening brackets. So vector OP, ON, now vector ON is equals to OP, and OP is vector P plus vector Pn, where Pn is a fraction, it's 1 over 3 into minus P plus Q, opening brackets, vector P minus a third P plus a third Q. We are opening brackets now, which is equals to 2 over 3 P plus a third Q. This is the vector ON. Kuna mwenye ataona? That's the vector Pn. ON. Okay, so let's move on. This one is 1, 2, 2, 3. So we have vector ON as what? Tuiandike place mahali ndio tukae tunaikumbuka. So ON is vector, it is equals to 2 over 3P plus a third Q. 2 over 3P plus a third Q. That is vector ON that we have worked out. Next is vector PM. ON and PM. PM, we are following which route? PN. PN vector PM. PM tunatafuta hii. So PM, we start from P, we go to O, and from O we go to M. So it is equals to PO plus OM. PO is against the direction of vector P, so we have negative P plus OM is a fraction of OQ. From O to M, 2 divisions. From O to Q, 5 divisions. So it is 2 over 5. We take 2 over 5 by getting what is O to M, 2 divisions. Then from over O to Q, 5 divisions. Then vector OQ, which is Q. And this is vector PM. So we write vector PM somewhere. Vector PM is we add ON, so PM. PM is equals to, we rearrange 2 over 5q minus p. Sawa sawa. Are we in agreement? Well, so back to our diagram. So we have worked out for vector PQ. We have worked out for vector ON and vector PM. And so far we have the 4 marks. Now we need to go to B. Anybody who has an issue on how the 2 vectors have been worked out? Are we in agreement, all of us? By show of your hands. Inua mkono if we are in agreement. Yes, Susan, we are in agreement. The B in agreement. Hata mimi, we are in agreement. Member number 7. Proceeds not in class. Because I have asked you to raise your hand. If you are in class, you do so. So it means Amanda Kula. All right, now you can lower your hands. We get back now to another section. B. Given that OX is HON and PX is equals to KPM, where H and K are constants. Determine the value of H and K. We substitute what we know in the 2 vectors that we are given in terms of H and K. So what do we know in the 2 vectors? So we substitute in them. So H is equal to OX is HON. And remember, we have worked out ON. ON is 2 over 3 P. Ndio iko huku juu. ON is 2 over 3 P plus a third Q. So we substitute in, we need OX. It is 2 over 3 P plus a third Q. That is OX. And we are also told that vector PX is equals to KPM. So we need PX, which is equals to KPM. And already we have worked out for PM. Our PM is tumeandika somewhere huku juu. PM is this one. So PM is equals to 2 over 5Q minus P. So the first thing to do is to interpolate this information. The vector OX and the vector PX. After interpolating, we can even evaluate and say vector OX is equals to 2 over 3 HP plus a third HQ. And Px is equals to 2 over 5 KQ plus or minus KP. So you have interpreted the information you are given. Now it is making some sense. Now, how do you find the values of K and H? We express one vector in two ways. Choose one vector out of the two. Let us choose one vector that we can express in two ways. I want us to go with the OX. Already we know OX is 2 over 3 HP plus a third HQ. That's one way. There is another way we can include PX and still get OX. So OX can be equals to OP plus PX, where our OP is P and the PX ndio iko nayo hapa. It is 2 over 5 KQ minus KP. Then evaluate, we like terms together, vector P minus KP plus 2 over 3 over 5 KQ. If we factor out P, which is common, we remain with 1 minus K, then plus 2 over 5 KQ. Good. We try to be kind of having a sequence, the flow of thoughts, the flow of the ideas. That one, interpret whatever you are given by substituting what we know. And the way the question would be organized is like we know where it is heading to. Part A, it simplifies the working of part B. So we interpret. So we have managed to express vector OX in two ways. Then we know that vector OX, it is equals to OX. It is the same thing. So let's substitute. Let us equate. So vector OX, the first way to get vector OX was the first way of getting vector OX. I want to check those who are writing. The first way to get vector OX, where we head in terms of H, is what? I want to choose one person here. I want to choose Abigail. You will guide me now. One way, OX is equal to what?
OP and PX.
OX is equals to?
OP, then PX.
No. Give me the final one. The final answer after we interpreted our OX in two ways. Let me guide Abigail. Abigail, what I am asking for is this one. Hii iko hapa. Umeiona? Unaona hiyo? Yeah, that's what I wanted. I also wanted another OX iko hapa. You already we are done with this one. We have interpreted until we have two ways. One OX, another OX. Sasa umeziona hizo
Oh.
Well, sasa vile umeziona, nipea hizo. OX ya kwanza, the one that has H, ni gani? Abigail, unaandika? Do you have a book somewhere where you are writing what we are discussing?
Yes.
Then from your book, read it for me OX in terms of H. Ile ya kwanza ni gani? Abigail is not writing. Now that Abigail is not writing, let me go to Irene. Read for me vector OX, the first one.
OX is equals to 2 over 3 HP
2 over 3 HP
plus 1 over 3 HQ.
1 over 3 HQ is equals to another OX, the second OX in terms of K. Ni gani? Irene?
Chami ingine sijaona.
Wewe. Tulisema mtu alikuwa anaandika. Do you have a book?
Yes.
Are you writing what we have been discussing?
Yes.
Then why is it that you cannot say that one?
I've not finished writing it.
And the way we are very slow. Nataka kujua mwingine kama ameandika. The second OX in terms of K. Tumetoka kwa Abigail, tumetoka Ivan. The second OX, yes, in terms of the second way of writing OX in terms of K. Read for me.
P. Into brackets 1 minus K. Plus 2 over 5Q.
Very good. I said we must be writing in a sequence as we flow together, not just listening. All right, our procedure is to express OX in two ways. One way that has H, another way that has K. Then now from there we equate the two ways. One way and another one. Then equate corresponding vectors. Vector that has P and a vector that has P. So we have 2 over 3. Yes.
Is it 2 over 5 KQ or 2 over 5Q?
KQ. 2 over 5 KQ. Ivan, you can see where we got it wrong. Okay, wait, that's okay. So 2 over 3 HP, it is equals to P into 1 minus K. P and P will cancel. We remain with, and then multiply by 3, and multiply here by 3. So 3 and 3 will cancel. You remain 2H. This equals to 3 minus 3K. If we rearrange, we have 2H plus 3K is equals to 3. Equation 1. So So we equate two vectors, corresponding vectors, the one that has vector p and the one that has vector p. After equating, we cancel vector p, we cancel with vector p by dividing by p both sides. Then we have a fraction of 3 multiplied by 3 by 3. Then 3 will cancel with 3. So you remain with 2h is equals to 3 times 1, 3. 3 times k minus this one. Rearrange 2h plus 3k is equals to 3. Tunaleta hii to the other side. So we have equation 1. We also equate the second one. Let's equate the second. We equate the one that has QH and the one that has Q. So we have a third HQ is equals to 2 over 5 KQ. Q and the Q will cancel. 5H is equals to 6K. And this is another equation. If we rearrange, we have 5H minus 6K is equals to 0. So we have another equation 2. So we solve the two equations simultaneously for the value of h and k. I want you to solve and get me the value of h and the value of k. 1 minute. Solve these two equations simultaneously to get the value of k and the value of h. Kimaliza unainua mkono. Ana amemaliza? Mwenye amemaliza tuambie. Raise your hand and give us the value of x and the value of y. Yes, gift. Gift, value of h. Unmute yourself. Gift, I saw your hand. Gift ni kama amepotea. Another person who has worked out for the value of h and k. Gift, you are not communicating. Maybe something wrong with your nini, with your sound. Try to talk. Gift, we are not getting you. Beth, I can see your hand.
K 5/9.
5/9.
H 2/3.
2/3.
No,
If you have
sir,
this one,
K 5/9.
K ndio 5/9 alafu interchanged na h ndio hiyo ingine, si ndio?
Yes.
So if you have the two values, confirm by raising up your hand. If you have the two values, if you have the same values as Beth, Mora is saying she has the same values. Ivin the same. Irene same value. Gift same. So we can agree that the values of x are the values of k and h, 5/9, 2/3. Now we move to the next equation. Roman 2b. Determine ratio in which x divides pm. X divides pm. So we get back to the diagram with our values. With our value of k and the value of x. We go back to the diagram. Now our k was for pm, so k was here. What remains is 1 minus k. And h was on ox, then 1 minus h. Now we want the ratio in which x divides pm. So we write the ratio p x is to xm. From p to x, we have k. And from x to m, we have 1 minus k. These are the ratios. So the value of k is 5/9. And the value 1 minus 5/9 is 4/9. If we simplify, k and k, 9 and 9 will cancel. If we multiply here by 9 and multiply here by 9. So our final ratio is 5:4. So x divides pm in the ratio 5:4. We in agreement? That's how we address the question. The question that is having the 10 marks, looking for the constant. So what is the best approach as per what we have? The best one is one, try to interpret the information into the diagram. In the diagram, try to follow the easiest routes. Avoid negatives, going against the direction. If you go against the direction, bring in a negative something. Then now the flow will be just that way. That one marks the typical question in vectors. I want you to try others. And in case of any question, then you will ask tomorrow. Right now, we were doing a topic and it is SOSA. So our SOSA today is equation of a circle. Equation of a circle. Sio TV. Equation of a circle. Equation of a circle. What are we expected to master before we answer questions on equation of a circle? The first one is general form of equation of a circle, which says general form of equation of a circle, where we say x minus a squared plus y minus b, then squared, is equals to r squared, where the center is a, b, and r is radius. So for us to start off doing anything in equation of a circle, we are supposed to see the center and the radius. You cannot work out for the equation of a circle without center and without radius. And then another point, we have a point which is arbitrary, which is xy. This is a point that where the circle is passing through. Where the circle is passing through a point xy. Still, in form of equation of a circle, we need to understand how to find the magnitude of a vector. Magnitude of a vector for point A, which is xy, and point B, which is x1, y1. So the magnitude of AB is equals to maybe which will be giving us the radius. Radius is the length, and length is size of a certain line segment. So for us to work out for the radius, we need to understand the formula of getting the magnitude. So it will be equals to the square root of x1 minus x squared plus y1 minus y then squared. So these are, we are taking arbitrary values, but these are coordinates. So we work with the coordinates of A and coordinates of B. Another thing that we need to know is after magnitude of a vector, we are supposed to have another knowledge on how to find midpoints. Midpoints will help us if we want to find the center. Center may be given the diameter. If we are given the diameter, maybe 2 points are the ends, A and B are the ends of the diameter of a circle. Then you are given the coordinates of A, coordinates of B. That is a circle. And then we have the points A and B. The point B is x1, y1, and the point A is xy. So we need the midpoint that will give us the center of the circle. So the center of the circle will be midpoint C, which will be equals to x1 plus x divided by 2 and y1 plus y divided by 2. So this will give us the center. Now with the center, we can easily find the radius. All these aspects are required for you to master, so that now you start bringing in the ideas as you are getting the equation of a circle. Another aspect that we are supposed to know, it is completing the square. This one will help us when we want to determine center and the radius when you are given equation of a circle. So when you are given equation of a circle, you can be asked to determine the center and the radius of the circle. So we need these aspects. One, we need to have the knowledge of completing the square. So we are going to complete the square for the equation in terms of x and equation in terms of y. Then we get the radius and we get the center of the circle that we are given it is equation. So this knowledge is enough then for us to answer questions. So we have said one, we need to understand the general form of equation of a circle. After general form of equation of a circle, we need to understand how to find the magnitude, whether you are given 2 points, A and B. How do you find the magnitude? And how do you find the midpoint? In an event you are given 2 ends of a diameter, we need to find the radius. We need to find the center. From the center and the magnitude formula, we find the equation, the circle. We find the center of the circle. And when we given the equation of a circle, how can you determine the radius and the center of the circle? So we need to find by completing the square, or in terms of x and in terms of y. So with this knowledge, now we get back to answering one question. Equation of a circle. Question of a circle, we have trial 3 question 13. Trial 3 paper 2 question 13. Trial 3 paper 2 question 13. Question 13. Good. The equation of a circle is x squared plus y squared minus 4x plus 8y equals to 5. Find the center and radius. Center and radius. This one, it conforms to what we. So here, this was center and radius. What should come in your mind is completing the square. So completing the square. So we have this equation. We have the equation x squared plus y squared minus 4x plus 8y equals to 5. When asked to find the center and radius, you rearrange the equation and we bring everything together. So the x should come together with another x. So x squared minus 4x. You skip some gap to avoid a lot of writings. And then we have plus y squared plus 8y. skip some gap, then equate to 5. So these gaps that you have left is for completing the square. So completing the square both sides. So how do you complete the square for the equation suggesting for the value of x? We add b over 2 squared. So our b over 2, ax squared plus bx plus c is equals to 0. Our b is the coefficient of the middle term. So negative 4 over 2 squared. And here we add 8 divided by 2 squared. We do the same on the other side, minus 4 over 2 squared plus 8 over 2 squared. So we are now at the stage where we are completing the square for x and completing the square for y. Then we take the square root of the first term. Square root of x squared is x, and we take the square root of this constant term. Negative 4 over 2 is negative 2. So the square root would be the number in brackets minus 2. Then we square plus the square root of y squared is y, and the square root of the constant term 8 over 2 is 4 squared. So the square root here will be plus 4, then squared. This equals to, we take the other side, we square. This is 5 plus 2 squared is 4 plus 4 squared is 16. 5 plus 4, 9, 9 plus 16, 25. This one gives us 25. And then we find the value, the general form of equation of a circle. It is x minus a squared plus y minus b squared. This equals to radius squared. So r squared is equals to 25. So r is equals to 5. So the radius is 5. Negative a is equals to negative 2 divided by negative 1, negative 1. So a is equals to 2. So the center a is equals to 2. 2. Minus b is equals to 4 over minus 1 over minus 1. So b is equals to negative 4. So this is the center and this is the radius. I want you to learn the art of doing these things. They're not very complicated. What you should work hard is to get the process, get the ideas and the concepts. Then everything will follow into its own place. So completing the square ideas will help us to determine the center and the radius given the equation of a circle. All right. Any question? I can see Gift. Your hand is up. Gift, and mute yourself. Gift has challenges in communication. Do you access chats? You can text. If you cannot, unaweza enda huko kwa chat uone kama unaweza text. Maybe I allowed you to text. That's how we find the equation, the center and the radius when we are given the equation of the circle. Let's attend to one more question, and then I will allow you to do the rest. Equation of a circle, trial 9, question paper 2, question 9. Trial 9, paper 2, question 9. Well, that's question 9. Ross, read for us question 9. Ross asome question 9. Ross is not in. Ross Yuko. Susan, read for us question 9.
A circle whose equation is x minus 1 plus y minus k is equal to 10. Plus 2.25. Find the coordinates of the two possible centers of the circle.
Well, very good. A circle whose equation is passes through 2, 5. Find the coordinates of the circle. When it passes through 2, 5, it means the 2 should satisfy the equation. The two values should satisfy the equation. So substitute. So when x is equals to 2 and y is equals to 5, the equation must be satisfied. It must add up or to whatever to 10. So substitute the value of x and the value of y. So we have x minus 1. So we are going to have 2 minus 1 squared plus. And y minus k, 5 minus k squared. It is equals to 10. So that's the first substitution. And actually, even if you don't know exactly what is going on, at this stage you are getting 1 mark for correct substitution. After substitution, I want you to work out until you get me a quadratic equation. Expand this one. 1 squared plus 25 minus 10k plus k squared is equals to 10. Confirm whether, I want you to work until you get me a quadratic equation. Expand quadratically. Uh-huh. Are you done? Umoja tu. An organized equation for this one.
K squared.
Sawa. Let's get back. Let me not rush. Tuanzie hapo. I know you have tried your way. Let's now expand. Let's evaluate. 2 minus 1 squared plus this is 5 minus k times 5 minus k. This equals to 10. 1 squared is 1. 5 times 5, 25, minus 5k minus 5k plus k squared is equals to 10. Like terms together. This is 26. 26, we bring 10 in here. So 16, minus 10k plus k squared is equals to 0. Rearrange k squared minus 10k plus 16 is equals to 0. Are we together? If we are together in this equation, inua mkono. Beth has given thumbs up. So it means we are together. Then we get back and solve this one quadratically. Which method do you want us to use? Maybe quadratic formula. K is equals to minus b plus or minus the root of b squared minus 4ac over 2a. Our a is equals to 1, b is equals to negative 10, and the c is equals to 16. Substitute minus, so 10 plus or minus the root of 10 squared, 100, minus 4 times 1, 4ac times 16, and then divided by 2 times 1. And our k is equals to 10 plus or minus 100 minus 40, 16 times 4, 64. 36, root 36, 6 over 2. So K1 is equals to 10 plus 6 over 2, which is equals to 8. K2 is equals to 10 minus 6 over 2, which is equals to 2. Are we together? We are together in this, Beautiful. All right.